All right, so tonight we're going to basically look at kind of what Spectrum is, what the team is, um, what do we actually do, what is a robotics team, what is an engineering team, like what are our goals, the competition that we actually compete in, kind of an overview of what the season looks like, and then our plan and schedule for this school year, and then also what we ask and what we can use help from our supporters like you all. Okay, so Spectrum is the engineering team from St. Agnes Academy and Straight Jesuit, so we're a joint program from both schools. Um, and really, our mission is to work with your students to get them introduced to a whole lot of different hands-on engineering aspects. We're also going to work on a lot of team building. There's a lot of competition that you get a lot of the same things you get out of being on a sports team. We do the same things in robotics or on Spectrum. A lot of confidence building. There's some public speaking involved. There's a lot of actual applications of the math and science that they're learning in school. Um, and there's a big presence on values and making sure that they're working towards a larger mission in what we can do to support our communities and things of that nature. Um, so a lot of it's all focused on our students, the students that are on our team, building them up and making sure that they are able to be successful when they go off to college and eventually into the rest of their lives. Um, we do that through the robotics program. That's what we're gathered around. That's our main mission, is building this competition robot. It's the thing that we kind of the campfire that the tribe gathers around, that sort of thing. But we're along with that, we're promoting the idea of continued education. They're going to fail a lot, and they're going to learn how to deal with that failure and pick themselves up and keep going. They're going to be able to learn how to use a lot of tools. They're going to learn and do things that they never thought they were able to do before. They're going to collaborate with not only our team members, but we actually work with a lot of different schools from the Houston area, around Texas, around the United States, and then even globally. And then we do a lot of work to give back and strengthen our communities in the ways that we think we're good at. There's a lot of things that being on Spectrum can provide, and it kind of depends on how much effort and time and interest each student wants to put in. But we do try to expose to a lot of different STEM skills. We'll talk about the different fields of engineering. We'll have speakers come in at different times. We may visit some different places, different demonstrations, expos, all sorts of things like that throughout our time. We've done bits and pieces of all of those. The FIRST program, the part that we're a part of, we'll talk about what FIRST is in a little bit, has a lot of scholarship opportunities that are only available to students who are participating in FIRST. There's a lot of ways that they can get scholarships for continuing their education, which is great. A lot of our students have gotten internships from connections and people they've met through the competition, either through competing or through volunteering at competitions and things. So there's a lot of different ways that they can get benefits from being on the team, not just from the fun and the learning that actually happens on the team. Our lab is based at Strake, so we have a room that has our tools and equipment in it, and then we also use a computer lab that's also a classroom on the Strake campus in a G Hall, the STEM building over at Strake. In that lab, we have, like I said, a full computer lab. We currently have a laser cutter in our machine shop, multiple 3D printers now, a CNC router that allows us to cut metal, and then all the normal drills and saws and woodworking tools as well, plus a lot of the tools needed to do the electrical for the robot. We have laptops and things to do all the programming, and just all the equipment we need to be able to sustain the entire program. Okay, so who are the people who are actually running this, and who am I? I didn't introduce myself to kind of do this now. So I'm Alan Gregory. I'm the head coach for Spectrum. This is my 20th season doing the FIRST robotics competition, starting all the way back when I was a freshman in high school in Central Texas. So then I graduated high school and came to Houston to attend Rice University. While there, I actually helped start a team at Lamar High School, my sophomore year of college, and I worked with them for 4 years. And then in 2011, I got the opportunity to come work for St. Agnes and coach their engineering team, and I've been in charge of the joint program since then. So this is um, 10 years of being with St. Agnes and Strake Jesuit. Um, I've done different engineering consulting things. I do a lot of different things on the side, and I also work with a lot of robotics programs as a volunteer, um, and working as an organizer for a lot of the different competitions, from volunteering at the first robotics competition, the one that we actually compete in, as a lead robot inspector. So I'm in charge of making sure all the robots at events are safe and meet all the rules. For one of the other competitions that we don't compete in, I'm one of the head refs, so I referee a lot of the matches locally and then also at the World Championship. Um, for a program called First Global, which it's almost like they tried to make it like the Olympics. It's a kind of a weird program, but either way, it's an international program. So then I've gotten to volunteer in Mexico City and in 2019 in Dubai. So those have been fun. So I do a lot of robotics things around the educational robotics community, kind of all over the world. But my main job, my main mission is working with Strict Jesuit and St. Agnes. There's several other mentors that are working with our team and our students. Suanne Bouvier is on the call, so she is super involved. She actually started just like you all. She was a parent on the team. Um, what was your you can tell your story, Suanne. You're here.
Oh, hi. So my son is a started he started on the engineering team, and then I helped with photos and publicity and helping run nonprofit events. And my background is training and marketing and working with teams and long range planning. So after my son graduated, I continued on with Spectrum. And so you'll hear the students um, talk about how scared they are to speak in public and talk to strangers because they're all introverts. And in fact, there are many times when they're with each other, they're not. But I work with them on building their confidence, talking to strangers, working when we work one on one. We are successfully help them develop interviewing skills, and so you'll hear them say there's a dean's list, or and that's an award through first where the team nominates sophomores and juniors, their peers, to compete against other students across the world, um, based on their academic, their community outreach, and their interest and their help on the team. And so we'll spend a great deal of time with them, prepping them for interviews. And I have asked parents and also outside mentors to sit in on panels, and we'll do mock interviews. And so the first time they do it, and they do it one on one, they're super scared. And by the time we work with them, they're so confident. And by the time they get to their interviews, they're like, okay, we've got this. Those interviews are super useful for them when they get ready to interview for college. Um, they have their internship, and so the students that we've worked with, the feedback that we've gotten from all of them is like, oh my gosh, it's been really wonderful. I remember when I first started doing interviews, I've used it in their real life. And so I work with the students with a lot of their soft skills. Um, so I'm the non-technical mentor on the team. I'll work with them on with the writing and the awards and talking about logistics. I write grants, and I also liaison with a lot of the parents, uh, corporations, and our community outreach.
Um, yes, thank you. Yeah, so as you can see, Suanne has embedded herself and is now an integral part of the team, and it would not run nearly as smoothly as it all does now without her. She's taken so much of a load off my plate, and allows us to do a lot more as a program. Um, in addition, we do have some faculty advisors. So from Strake, Jacob Walker and Damon Tran are both Strake teachers who have been helping us. And then this year from St. Agnes, I forgot to update the slide. My apologies on that. John Stegemeyer is a physics teacher over at Agnes, and he's going to be working with us as well. So we have several faculty members that will come and help with logistics and communicating with the schools and all of that sort of thing. Um, okay, so a couple things. So um, at this point, this meeting normally happens a little earlier in the semester. We had to push it back for a variety of reasons. But so just so everyone knows, like, this is our team. Everyone is welcome. We've never had to kick anyone off the team. We're everyone is free to join. We try to work around people's schedules, and no experience is necessary. We don't expect people to have done programming camps or robot things before. People can come in with whatever knowledge they have, whatever level they're at, and we'll happily teach them and find ways for them to learn and contribute to the team in whatever ways they can, and then they'll grow as they're on the team for multiple years. Um, we try to be incredibly flexible. We've pretty much had a student who's been on Spectrum and who's done really well on Spectrum also do pretty much every other club or sport that you can imagine. They've pretty much done it. There's a few that haven't just because there's not a lot of people in certain ones of them, basketball team and stuff. But most of the other sports we've had students do the sport and our team and done well at both. So it is possible. It's just a matter of them figuring out how much time they want to commit to what and what their priorities are, and they can work through it. But we are pretty flexible on schedule, especially when we start getting into what we do in the spring and how that works because we're meeting so much. So there's almost always a way for them to be able to carve out time where we are in the lab and working. Um, we do ask that all the students are really curious and interested. One of the reasons I do this, and the main reason why I like my job and I love what I do, is I really like working with students who are excited and want to be there and they want to learn. And we get a lot of that with our students from both Strike Jesuit and St. Agnes. Um, and then we said we want our students to learn and help make the team better in whatever ways they can. And ideally, they're having fun and enjoying the experience while they're doing it. So we do a lot of work to make sure they're getting to know each other, they're bonding. This is a really hard thing we do, and you'll see it as we get through it. And it's a lot easier if you know the people you're working with like you, and you can joke with them and have fun with it, because it is not an easy task that we give the students to do, and that we help them through, and that we're working together to accomplish. Um, the team only works because we have awesome team members. Like, this team was started completely by passionate students before I was ever involved with the program. There were students who were doing different robotics competitions at both schools, and they decided amongst themselves that they wanted to join forces and do this harder thing, this FRC competition that we're going to talk about in a little bit. And so from there, it's always been the students moving along and getting the program further and further and making us better and better by their being dedicated to it, by them figuring out ways that we can improve, by them putting in the work and learning and asking good questions and figuring out how we can be better as an entire program. Okay, so looking at what FRC is. So FRC is the acronym for the program that we compete in. It's the first robotics competition. So it started all the way back in 1992. So we are going, this past year would have been 30 years, but we're going into our 31st season. And the vision when it started was to transform our culture by creating a world where science and technology are celebrated and where young people's dreams become a dream of becoming science and technology leaders. And so that's a big part of what we're trying to do, is make sure that all of our students understand the importance of science and technology and what it does for everyone. FIRST stands for Inspiration and Recognition of Science Technology. And then FRC is the first robotics competition. And this is the program that we're in. FRC is basically the varsity level, so it's the largest and mostly hardest competition you can do as a high school robotics student. There are a number of different high school robotics competitions. FRC is the biggest one, basically. Teams of students and mentors. So this is actually one of the ways where it is different than a lot of other programs and a lot of other high school programs. FRC was designed from the beginning to have students working alongside mentors, alongside their teachers, engineers, scientists, people from their communities, to help solve these problems. It is not something that the adults have to be completely hands off. We are working together to solve whatever the problem is each year. The teams can be formed in all sorts of ways, so it's not just like a normal kind of district or UIL competition where each team is from a specific school. Sometimes that's the way, but just like our team, where we're the combination of two teams, there are teams that are entire district teams where they'll have 3, 4, 5, 8 high schools all feed to a single team. There are community groups, so you might have teams run out of a Boys and Girls Club or a Girl Scout troop or a Boy Scout troop, 4-H clubs. There's teams that are just run out of people's garages, and they have multiple families get together and they recruit students and they do it that way. There's all sorts of ways that an FRC team can exist, um, and none of them are right and wrong, and we all compete together, and it just sort of works. And our mission is for all of those teams is to make sure the students are having a really good experience. Um, yeah, there's no restrictions on what work an adult can do and what work a team can do. Our team works largely because of our student base, so I'm largely the only technical mentor. So I'm the mentor who's mostly working with the actual robot side, the design, teaching them all of the stuff they need to know to use the tools and the equipment, and actually build the robot. Um, and so I'm kind of guiding them through the process, but the students are doing the vast majority of the work each year to actually build our robots. Um, FRC is an international competition. These numbers are pre-pandemic, so these are probably going to drop a little bit. We're not entirely sure how registration is going to go for 2022, but we'll see how this all goes. But there were just about 4,000 teams worldwide from 34 countries. And so when we actually get to the World Championship, we get to compete with a lot of these teams from around the world, which is very cool. We've had teams from like Australia and China come visit our lab because the World Championship happens to be in Houston, which is convenient for us. So they've come visit our lab beforehand and stuff, and we got to meet and talk with them, as well as like actually go and compete with them at the competition. Um, and so this is where FRC gets a lot different from pretty much all the other normal high school sports or normal high school competitions. Every year in FRC, we're given a brand new game. So we know we have to build a robot. I can tell you, we know we're going to build a robot starting in January, but we don't know what the goals for that robot are going to be. We have no idea what the rules are. We don't know how the game works. We don't know anything. So the objectives, game pieces, playing field arrangement, how we score, all of that stuff doesn't get announced until kickoff in January, which is normally like the first Saturday, and we'll look at the schedule a little bit later. Um, so there, over the years, there have been all sorts of different things. So this past year, the robots had to be able to do a pull up on this bar, and you were trying to like level it with your partner. That was like the end game. They also had to launch these yellow balls into goals. This was our 2019 robot, and it had to be able to hang these like round plastic panels that had Velcro on them on these certain spots, and then also score orange balls behind them. So there's drastically different games. The robots look very different. And so a large part of the challenge is deciding what you actually want to build and how do you actually want to play the game to maximize your potential. Um, each year we do design, build, and operate a new robot. So we're figuring out the strategy. We're figuring out what components and parts and materials we want to use to build that year's robot. The rules for the robot size and all the specifications change. So some years they're allowed to start at certain heights, be certain dimensions, expand in certain ways. There's a pretty long rule book for exactly what you're able to do each year. And for most of the match, the robot is driven by student operators. There's a portion normally at the beginning of the match where it is autonomous, but those rules can all change and things too. We don't really know how much of the match is going to be autonomous or how much is going to be human driven until we actually find out the rules for the game next semester. Another way that our competition is a little bit different than most other high school sports is we're not just competing alone. So in every match, there are 6 robots on the field, and they're divided into 2 alliances. So there's a blue alliance and a red alliance. And for each match, an entire alliance wins. So in this match here, so this was a 2016 match, right before the match was about to start. We had our robot, and we were partnered with these 2 blue robots, and we were competing against these 3 red robots. And so that means that we only build the one robot that we're competing with. So these are all built by other high school teams from different schools, different communities, possibly from all the way around the world when we go to like the World Championship. And so we have to work together to try to win the match. And so the reason we're trying to win matches is that's the eventual way that we're able to win the competition. So we want to win matches. That lets us win events, and we win awards as well. So roughly a match is about 2.5 minutes, so they're pretty fast. One alliance of teams wins by scoring the most points in most years. That's the rough way it works. The event winners are the alliance of teams who actually win the playoff tournament that happens at the end. And then at each event, there are judges who go around and actually are talking to teams, not just about their robot. They are talking about that, but they discuss things with the teams. They have the teams show what they've built, but the students are also talking about what we do as an entire program. And there's awards not only for the robot designs, but also for team attributes and outreach efforts and a lot of things like that as well. So it's not just the robot that gets rewarded; it's everything we kind of do as a team. Um, Two of the biggest philosophies and the foundation of what the culture of FRC is were introduced by Dr. Woody Flowers. So he passed away a few years ago in 2019, but he's pretty much the grandfather of competition robotics. So he was a professor at MIT. He taught a course called MIT 270. And pretty much in that course, they figured out, this was back in even the early 70s, they started having their students design and build mechanical contraptions to compete against each other. And as it kept going, decade and a half into the late 80s, they actually were able to have their students start building robots and competing with them. And so that's where the foundation of getting students to build robots and using that as a way to get them to really get them that hands-on experience so they can really learn came from. And he's one of the co-founders of FRC along with Dean Kamen, the person who invented the Segway and a bunch of other things. His company and him have invented many things. And so they work together to actually get FRC started and to get students actually doing these robot things. But two of the principles that came from his coursework and things that he was teaching his students that they kind of pushed into FRC and have come pretty much as like the bedrock of our culture are grace of professionalism and cooperation. And the kind of the core principles here are that we are competing like crazy, so we very much want to win, but at the same time we understand that there are bigger things at play than just each competition. We want to make sure everything is happening fairly. We want to make sure we're empathetic and kind to all of our teammates, competitors, volunteers, everyone at the event that's making this event happen and that allows our seasons to happen and allows us to kind of be in this program. In addition to that, for cooperation, we're going to be helping other teams at the event. So a lot of times we're not just working on our own robot, we'll be loaning parts, giving advice, talking about how to fix different problems that are happening throughout the event to all of the teams that are there, sharing resources, and just making sure in the whole that everyone that's at the event is having a really great and positive experience. In addition to all of the robot stuff, FRC teams are normally, like I've already talked about a little bit, we're doing a lot of outreach and we're working to expand STEM opportunities and address needs in our community. So there's a variety of things that we do as a team that we have done throughout the years. Things are a little bit different right now because of COVID, but we're still making things work and doing what we can. So things from a program that we did for multiple years called Construction, where the students would actually design a full 3D model of a sculpture that they would build out of canned food, and we'd compete against actual architecture firms in this one. We'd also do demonstrations for this was like a Cub Scout troop. We'll teach various classes. So for multiple years we were doing them at a Boys and Girls Club. This past summer we partnered with a nonprofit called My Connect Community, and we did it at the KIP Connect school down Bel Air, and we were able to do a summer camp there. And so we have multiple different ways that we're able to teach younger students and provide a service to our community. Real fast, because this question gets brought up a lot. So the reason this spectrum thing exists and what 3847 is team names and numbers are just part of FRC. You can kind of consider the number similar to like a race car number. It's like on the side of the car. The numbers are on the side of the robot. It just makes it easy for us all to identify all the other teams uniquely, because sometimes they do have they'll share names or very similar names. And then the name, it was just when I came on board, we met with the team and we kind of decided we wanted a name that was unique and would work, that was kind of different from all the other teams and that wasn't super generic. And we were trying to figure out what made sense with the combination of the two schools and things. And somehow through that meeting, Spectrum ended up being the result. And we've had that name ever since. And now it's pretty well known inside the larger FRC community. for what we're able to do for a lot of the other teams. Okay, so what do our actual students do? So what does all this mean now that we have this event that we have to compete in? What are like the individual tasks and things? So largely we break them up into about 7 categories for what we're doing on the team. Um, we don't split the students or like assign any one student to a specific category to where like we have someone who's only working on media. Um, most of the time we're going to try to have the students do multiple different things so they can get a feel for everything that we're able to do on the team and kind of can choose what they're actually interested in and what they don't. Normally after a year or so, or even that first year, they'll kind of figure out where they want to specialize and where they'll be, where they'll spend the most of their time or what they think they're really good at. But even then, we'll often still need help in other areas, and we'll pull people who are. We've had people who are normally the photographer, but they'll also come and do stuff on the robot or do other things. It's not like they're only this one thing and that's all they do. So we're going to try to make our students as well-rounded as we possibly can. The build is kind of the obvious thing. So we have to build a robot, so we need to have tools to do that. So it's learning to use the tools that are in our lab. Some of the CNC equipment is a little bit more advanced, so how you can actually get the laser cutter and CNC router that are able to make parts kind of for us, get them all set up and have the machines running. Also the 3D printers. It's also making sure we're organized and that we can actually continue to use the shop and maintain all the equipment and everything like that. And then it is also the actual robot assembly and construction. And then each year we also build practice field elements, since we don't have the full plastic and metal field that we'll use on the real field. We'll build wooden versions of a lot of those so we can practice before we actually go to our events. Design is where we're going to be learning how to use CAD or computer aided design 3D modeling software to fully model our robots before we build them. So we'll do all of the layout and assembly of the robot virtually before we actually start cutting any of the metal or cutting the parts to actually build it. It's also where we're going to learn a lot of the concepts and principles of how all the robots function and why we design them in a certain way. It's also where we test and improve a lot of things. There's a lot of iteration. We'll build something once, realize it's not quite right, and then we have to change it and tweak it and make it better. And a lot of this is going to be the practical aspects of mechanical engineering and how we can do different material properties, all sorts of things like that, to how we can actually build the robot and have it be successful. Our controls tasks are how we actually get the robot to move and how we get it to accomplish the various things it has to do in the game. So this is going to be the electrical and the programming of the robot. So we have to wire it, we have to connect all the motors, we have to connect sensors, all of those things get together on the robot, plus we have to actually write the program so that we're able to control it and have it do its tasks autonomously as well. There's a lot of things that go into that to make us to make our performance on the field better by having a better program and making sure all the electrical is reliable, isn't going to fall apart or disconnect or anything while we're actually having a match. The strategy subgroup is the part that I think if you haven't ever seen or aren't embedded in FRC enough that you don't even realize exists on most of the teams, there's a lot of our work and actually a ton of effort goes into figuring out the strategy for what we want to do each year. So what do we want the robot to do? Before we even can start designing the robot, we have to decide how do we want to play the game at all. But then we also have to figure out how do we want to play each match. And since, like we said, each match we're partnered with 2 different teams and we're against 3 other teams, each match is very different from the next. So we're looking at all of the matches at an event. So we're taking data on each robot so we kind of know what each robot's capable of doing. We have students who are figuring out and kind of predicting what a match is going to look like and what gives our alliance the best chance of winning. So we have to communicate that match strategy. We have to be able to communicate to the other teams what we believe the best match strategy is and for how they need to fill that role and what we need to be able to do as an alliance to win. We actually build a whole scouting system to take and collect all of that data so we can know so we'll know exactly like how many balls each robot scored into each goal. Um, all of that sort of thing we'll be able to collect throughout the event. Because at the end of the event, at the end of the qualification time, if we're one of the top 8 teams, we get to choose our 2 partners for the playoff round. So that's another reason why we take all of that data, because it's really important for us to choose which robots we think we can, or which teams we think we can compete the best with to possibly win the event. And then we'll also even be watching matches from around the world. There's competitions happening all over, and so we want to see how other teams are playing the game. Maybe they're doing something unique that we can then use to make us ourselves better at future events. So there's a lot of work that goes into strategy on the team, and this is a lot of what we actually put a lot of time into in the competition season. Um, Media is photography, videography and video editing, graphic design, social media. We have our own website that we create and maintain. There's a lot of things we can do inside of there that we need to do throughout. Some of it is for the awards that we get and like preparing judge materials, um, and then also just for better exposure in the community. We'll work to try to be in some of the local newspapers. Any of that sort of thing kind of falls under media. And then we do have a whole kind of award section of things that we're working on. So 2 of the biggest awards, or I guess the biggest award at each event is called the Chairman's Award. And that is a special submission we have to do, where we have to write an essay and create some other answers to some short answer questions that we work to prepare. So we actually are started that already. So we've had 2 meetings in the year, and it's not due until the end of February, but we're working on it now because we have that assignment. So we're going to try to get a pretty good head start on all of this. In addition to that written submission, we have to do a presentation. So we'll have 3 students actually present to a few of the judges, do about a 7-minute presentation talking about our team and the impact we've had on our community. And then we'll also prepare a magazine each year, so we can kind of explain the history of the team and what we've been able to do to the different judges. And we also have students who are specifically tasked with like talking to the judges about the robot, because then the pit judges will walk around and talk about the different aspects of the robot for those awards too. So there's a lot of things that go on as we're preparing for the event to put ourselves in the best position to win awards. And then outreach we kind of already talked about, so I'm not going to go over that too much again, but we also will volunteer at other robot events. I think that's the one thing we didn't really talk about. So we'll go to the robot events that we don't compete in. So there's a lot of, like I said, there's a lot of different levels from middle school and high school, elementary school, and we'll volunteer and have our students referee or help with the field setup and any of those things that are happening at those events. Okay, so quickly, we can talk a little bit about timing and how the FRC season works. So the start of the FRC season is in January. So it's normally the first Saturday in January. This coming year, it has to be later, so it's not on the 2nd, so it's January 8th, because I don't like it being too close to New Year's Eve, or to New Year's. So it's January 8th, so it's the Saturday as soon as the students are back in school. It's that first weekend this year is kickoff. There's a live stream that happens from First Headquarters, which is in New Hampshire. So everyone around the world is finding out the game at the exact same time. So they release a game animation and the game manual. And inside of there, we have all of the rules about what we're able to do with the robot, how the game is going to be scored, how advancement works, how we win events. All of that gets told to us on that first Saturday. And really, we can begin designing and building our robots. And so from there until our first competition is what we call build season. So this is where we're going to we actually get the game piece, so we figure out what the robot's gonna have to manipulate. We figure out how to do the full 3D designs within the CAD software, so we know exactly what the robot's gonna be. We manufacture and assemble the full robot. We'll program the robot, and then we'll also test and practice with the robot before the first event. So there's a lot of stuff that get crammed in there because our first events happen roughly a month and a half after kickoff. So we'll start competing right at the end of February after we found out the game at the beginning of January. So it's really fast and really compact time frame for how quick we have to get those robots or the robot fully together and operational. In the system that we're in Texas. So we have district events. So these lead to a district championship, which is the full statewide. It's actually Texas and New Mexico. New Mexico doesn't have very many teams, so it normally isn't. It's mostly Texas. There's about 200 teams in our district, and so we'll compete to be one of the top. Depending on the year, 64, maybe 80, depends on how many they decide to bring to the Texas State Championship. But our points here at these two district events, you earn points, and if you're in the top or so teams, you get to move on to the state championship. It is unlikely we'll ever miss the state championship. We'll almost always make it. It would be something very weird would have to happen if we didn't qualify. It's possible. It would just be a weird year. The district championship happens in early April. Oh, I left that from the 2021 side. You can ignore the 2021 stuff. Those aren't happening. It should be in early April in 2022. And then if we perform well at the district championship, we'll move on to the world championship, which is in mid-April. And there's actually two. It's a little bit weird. Each team only competes at one. So there's two world championships. There's one in Houston and there's one in Detroit. There were too many teams, so they decided to just split the event. It's a bit odd, but basically the New England and the northern U.S. teams go to Detroit, and then most of the southern U.S. and the West Coast come to Houston, and then a lot of the international teams also come to Houston. And it happens to be that we're in Houston, which has been very convenient for us. We've been here since 2017. So before that, we were competing in St. Louis, which is definitely a bit more of traveling. It's nice and easy that we're all here, and it's much easier for family and everyone to attend the championship. It's a really cool event. It is packed. There are 400 teams at the World Championship. So it's a really big event. It takes over the entirety of George R. Brown Convention Center downtown. Okay. And then once the World Championship happens, everything from then until kickoff is technically the off season. So it's really our summer and fall is when we're not directly competing in official FRC events, but we will have in normal years, we'll have off seasons, which are events that are run by individual teams, and they'll get a whole field together. They'll get all the volunteers, they'll register teams, and we'll have events roughly about once a month, starting in June, going all the way to October in a normal season. We do host one, so we'll talk about that a little bit later. So we host an event in the Straight Jesuit Gyms in mid-July, which we should be back to doing in 2022, assuming everything is reasonable, unlike it has not been in 2020 or 2021. So our last one was in 2019. But this is also the best way to get students trained to actually experience what the competition looks like before they do it in the real events. Okay. I did that about time. So before we get into our plans, I do want to show what a match looks like because I didn't do that earlier. So this was an event that we were able to compete in June. So we had an event at the Alamo Dome called the Texas Cup. So this was the only event we had in 2021. And so this was a match. Let me see what we can do. So this is our robot here, 3847. This is also our robot here. So this is not normal, but we happen to have two robots at this event. There's a lot of things that went into why. So this was the robot that we built in 2020, and then this is the robot that we built in 2021. This was this robot's first event, so it had some issues because we built it in a very big rush, and we didn't have a lot of time to kind of tweak and fix some things on it. But it did work reasonably well.
4063 elegantly putting up every shot for the Blue Alliance, making it all count. 148 taking a quick power nap. 4063 looking for some more power cells. Spectrum Junior and Spectrum Senior looking for a few more.
So in this case, we're the Red Alliance versus this Blue Alliance here.
While they're sleeping on the job. 7492 looking for another angle for the Blue Alliance. Blue Alliance might be able to.
So like this robot is trying to play defense and prevent us from scoring.
But the Blue Alliance captain 9892 pushing him away. Spectrum Junior is shooting too high. Spectrum Senior has them covered. 148, Awoken. Now 4063 is passing Power Cells over to their side of the field, over the control panel. What sportsmanship for the Blue Alliance. 98-92 still play some defense on the Spectrum bots. Spectrum Juniors protect against Papa. Spectrum Senior.
Yeah, the announcer got a little strange in this one.
Spectrum Junior going after a few more Power Cells. From downtown, 74-92, the Cowbots nailing shots for the Blue Alliance. 4063 passing more Power Cells over for the Blue Alliance. Spectrum Senior unloading for the Red Alliance. 148 now springing back alive thanks to some help from Spectrum Senior. 148's back, and they're looking for Power Cells as quick as they can. 74-92, a few last-second shots. The match is still neck and neck. 148 now looking to be stuck under the control panel with the Power Cell under them. The Spectrum family looking to go all the way up. 74-92 and Tricks Are for Kids for the Blue Alliance. Looking to do the same. We could have two double climbs here on the Fun Field Lone Star. Spectrum Junior and Senior.
Yeah.
The Blue Alliance.
So these are the robots have to do a pull-up at the end. Their goal is to balance the bar. We didn't get it this match, so we're kind of hanged at this weird angle. But we did get it balanced. So, yeah, that was our latest event. We did pretty well there. We made it out of our division into like the final 6 alliances or so, and there was like a round robin to finish it off. So we did relatively well. Coming up, so how things are working this year. So I will send out the slides to everybody at the end of this, so you can like click the links and stuff. But calendar.spectrum347.org does take you to our Google Calendar. We've done a pretty good job of keeping this up to date this year. A lot of times it gets out of date. I've actually been on top of it. So this has most of our meetings listed, and I try to get whatever our weekend times and trainings are about 2 weeks ahead. We'll try to have the signups and things go out for the students to know what they have coming up on the weekends. And so that is useful. You can add it to your calendar, your student's calendar, whatever works. Partly because of COVID and just how many students we have, it doesn't really make sense for us to put the 40, 50 of our students inside of a single room at the moment. It just doesn't seem reasonable, especially for the things where I'm largely just teaching, kind of like lecture. It's easier to have those be virtual. So Tuesday and Thursday nights at 8 p.m. we have our own Discord, so we do it on Discord, and that's where we're doing sort of the direct sort of training and how the robot concepts and all work. Tuesdays is mechanical, so we're going over robot design and then how to use the 3D modeling software. And then Thursdays is controls training, so we're talking about the electrical system and how to program the robots. And then there's a few other things and meetings that we'll have throughout the semester. So some of our Wednesdays are awards nights. We have some like team management nights and things as well. We're just kind of figuring out what we're all doing as a team. So all of those happen on Discord, and we can do those virtually, which works out pretty nicely. For in-person training, the way we're pretty much doing things is we're having sign-up slots, and we're doing small group sessions and project sessions on Friday, Saturday, and Sunday spots. And this has been working out pretty well. So those have been going out in a weekly email to the students about what to sign up for and when. And then we've done different small projects to introduce them to how to use some of the tools. We did a 3D printer training. We just did some programming training this past weekend. So there are a lot of things going on, and we try to be flexible enough around the days where most of the time they can find. We'll normally do 3 or 4 different windows where they can sign up on those different days. Total across the weekend, not 3 or 4 on each day. That'd be way too much. Each session's 2.5 to 3 hours long. Okay, so then most of the days after school, the lab is open. We haven't been doing too much, kind of intentionally. We don't want too many people there, but we've had people, if they have come in and have questions, if they want to they design something, or if they want to 3D print something, they can start the 3D printer up. There's some tasks and projects that we have going on after school every once in a while. But largely it's been pretty tame on the normal weekdays, Monday through Thursday. And then I forgot to delete that part. We will not have fall robot competitions. All of the plans we had for fall robot competitions all got canceled due to the COVID spike. So just like everything, a lot of our 2020 and 2021 season. But 2022 is looking promising. We believe we'll have events. and I think we'll talk about that in just a little bit. So some logistic stuff that I didn't. The slide should probably be further forward, but it doesn't matter. There's no fees to join the team directly. People can be on the team and never pay anything if they want to come and hang out and see how the team works. That's great. If students do want to buy apparel, their prices, it's in the lab. They can just come by any day, cash or check. If it's a check, make it out to St. Agnes Academy. That's where our normal budget comes from, or our normal, like, the account we use comes from. And then team members do pay a portion of the travel and food for events when we go. It's not too much. We try to keep it as cheap as reasonable. So if a student went to every single competition we did, which would probably be, I don't know, 8 or 9 in a year, most years it's somewhere around $750. It's not going to be too expensive, and most of the time you don't have a student going to every single competition. Sometimes they will, but it's only if they've decided that this is what they really want to do. Commitment, there's no one meeting is going to be required. They're not going to be kicked off if they miss a meeting. Like I said, we try to be very flexible. All that being said, it does take time to learn and do this. So if they're not actually showing up at all, they're not going to know what's going on. They're not going to have as good of experience as the students who are putting in the effort and figuring out what we're doing and learning and coming to all the different training activities and all the stuff available to them for them to take advantage of. The most activity is in the spring, but if they're not committed and doing stuff in the fall, they're going to be a little bit lost in the spring. It's not saying they can't do it. We've had students who joined in January and have been great, but they just have to know they're going to be a little bit further behind, and they're going to have to work at it a little bit more to figure out what's happening, and they'll have to ask more questions and things. It's definitely doable, and we'll work with them. But if they can find time in the fall to do stuff, they'll definitely be ahead, and the spring will be easier. Okay. I thought there was a slide. There's not a slide. Okay, well, I'll talk about it here anyway. The timing for this spring. So once we get into the spring, things may look a little bit different. We're not entirely sure how they're going to look in January, but the way we have been doing it in the 2019 and into 2020 for January and February is largely the lab is open for some amount of time, basically every single day. So we'll start that January 8th, and we will have someone working in the lab every day from January 8th until our first event in the end of February or the beginning of March. And so a lot of that allows students to have different shifts, and they can come in at different times. It's definitely more preferred if they give a longer block of time than if they only come a single hour every day after school. By the time we get set up, by the time we're doing things, there's not a ton we really get done between like 3 and 4. It's much more preferred if they come 3 to 6, 2 days a week or something, or if they come for a long time on Saturday or Sunday. Those are definitely a lot more time where they can actually get stuff done and actually be able to get accomplished than just trying to help out with whatever's happening right at the beginning of a meeting 3 to 4. We'll normally have students in the lab till 7-ish on most weeknights. Like we'll have students who do something else, so they'll go study for an hour or so and then come back. There's a lot of different ways they can do it. They can work into their schedule and make it work. And like I said, we're pretty accommodating to things. But I know it's just not as good of experience if you just expect your student to be there for an hour every day after school. It just doesn't work very well, especially in our build season. They're not able to be as engaged as they would like to be. Okay, so what can our supporters do for us? So we're trying to be a little bit more organized this year, partially because things are virtual and it's harder to see everybody and get things done. So we did start the Spectrum Supporters Slack, so multiple of you have been invited to that. If not, there's a little form in the email that had this meeting in it that you can go fill out and click yes, you want to be there. And that's just the messaging platform that we use for the team, so we're going to use it for this as well. So then we can organize meals and gatherings and everything else through that platform. If you have questions, that's a great way to get them answered. But pretty much Spectrum Supporters are anybody who wants to support the team, so parents, guardians, family members, step-parents, whatever. And then we also have some alumni in there who are helping the team. Any of the advisors, anything like that are in there, so we can all kind of organize around giving the students the best experience we can. Some of the main ways we ask supporters to help is, especially once we get into the spring semester, we're there in the lab for pretty long hours, so having snacks and also meals brought in is a big deal. So we definitely ask for parents who can to contribute, um, either bring snacks in that your kids like, or sign up. We'll have sign up. We normally do a sign up genius to do, different sign up slots for when you can bring a meal, and we'll tell you how many students and things. Um, or you can also just donate money to us, and we can use that to buy things too. Both work. Whatever's easier for, your family. And then we also try to do some different fun gatherings. So, um, in different years, we've done like end of the year pool parties and things. All of this is still a little weird because of COVID, because again, it's not super responsible to have a bunch of people together right now. Um, so we've been limiting them. We've done some different virtual things, but hopefully, as we get through, the semester, it should be a little bit easier and into next semester, to do some of these kind of fun gatherings. So if you have ideas for a way that we can do things that make sense, that we can just get the students out doing something fun where they can bond and get to know each other, and just kind of have positive experiences together, we're open to that. So that's one of the ways that we can definitely use the Slack to help organize those things. Um, we also, ask that parents help with some of our bigger events. So towards the end of next semester, so towards, into May and July. In May, we try to have an end of year banquet, which again we have not been able to do for the last 2 years, sadly. But we should hopefully be on to do it in May this year. So having some parents help organize and plan that is very helpful. And then the off season that I talked about earlier, so when we actually hold our event at, Straight Jesuit, that's definitely when we need as much help as we can get. We have to run the concession stand there. We have to organize all the volunteers and organize all like the volunteer meals. We have to do a lot of setup around campus. There's a lot of stuff that goes into that event. We'll have anywhere from like 32 to 40 teams at that event. So that puts us into, several thousand people there, for, 2.5 days. So it's a pretty big deal, and we definitely need all the help we can get. Um, Sue Ann, are there other, before I talk about corporate stuff, is there other stuff that I
Yes,
forgot about?
this fall we'll need some parents to help be mock interviewers when
Yes.
we start running all of our juniors and some sophomores and any of the seniors who want to participate who didn't last year in doing the mock interviews.
Yeah, so that we'll definitely get a sign up out on the Slack for that as well. Um, so if that's something you're willing to help with, that would be awesome. We definitely want to try to increase that part of the program. We had normally only been doing it for the people who would be nominating for awards. We're trying to open it up to any sophomore and junior who wants to do it, so that they can be more prepared to do all of, their interviews that they'll have to do for college, for, anytime they're just talking to judges for our program, and really just in life when they have to talk to someone about themselves and things like that.
And we're also looking for opportunities to demo our robot at different offices. If you at your office, or opportunities. For instance, one of the parents last time was able to invite the robotics team to go look at the robots at Memorial Hermann. So we were able to see the robotic arms. The students were able to operate them, and it was really, really excited. And now we have one student that's interested in going into robotic surgery.
Um, yeah, so in addition to that, any other things where, depending on what your jobs or corporations or, community ties, different clubs, organizations, that sort of thing, if there's ways where you think the robotics team can partner or work with or do a trip or demo or something like that, we're happy to definitely consider those. If you have ways for, matching gifts and volunteer hour donations, I know many of the oil and gas companies, if you volunteer for certain amounts of time, they'll able to, donate money to our program. Things like that, we're always happy to figure out how to take advantage of, when they're available. Um, like I said, there's multiple times where we'll ask for volunteers for some of our events. Some of the other events, also exist. So if you want to volunteer at the actual like in-season competitions, there's opportunities for that. There's just a lot of different ways you can get involved, if you'd like to, and hopefully with the Slack we'll be able to make that a little bit, easier this year as well. Um, yeah, we've had students intern at companies that parents worked for and things too, so that's always interesting. Kind of any way where we can get that you think can benefit our students, we're definitely open to suggestions and taking those ideas on. Okay. We do have the handbook this year. It's just another slide deck. Actually, we really like slides. It makes it easy for me to organize and put everything on them. So your students all have this, but I linked it here too. So if you want to go through and read it, you can. And then really, I'm just going to open it up to questions.